Hello, thanks for clicking, and welcome to a pre-narculus production, our fifth event in partial fraction decomposition. This is our final event through partial fraction decomp. So today we are going to talk about partial fraction decomp type 5, improper fractions. So there's that word again, improper fraction. We've talked about, in a couple of the videos, the difference between a proper and an improper fraction. All of the fractions that you have started with in each problem and been asked to decompose have been proper. If you go back and look at all of these fractions, all of them were proper. The degree in the numerator was always smaller than the degree in the denominator. Every one of them, no matter which one you look at. However, today we're going to talk about what happens if the fraction is improper to start. So an improper fraction means the degree in the numerator must be, numerator must be greater than or equal to the degree in the denominator. What if the degree on top is bigger or equal to the degree on the bottom? What you're going to have to do is first long divide. Everyone's favorite mathematical operation since Algebra 2. You're going to have to long divide the fraction to get something that's proper. Okay, so let's show you how it's done. It basically involves you adding one extra step to the partial fraction decomposition. Let's try x to the fourth plus 5 over x cubed minus x. If you look in the numerator, we have a polynomial with degree 4. In the denominator, there's a polynomial with degree 3. The degree 3 polynomial will go into the degree 4 polynomial, so you need to long divide. You cannot simply go set up your fractions until you have long divided. Otherwise, you will get an incorrect answer. So I need to take x cubed minus x and divide it into x to the fourth. Now, if you remember, we hold spaces for any missing degree terms. So we're going to put zeros for x cubed, x squared, and x. And then we're going to put 5. And now we're going to figure out x cubed times x would be x to the fourth. X cubed times x is x to the fourth. And then we have a negative x squared. And remember, you're going to subtract whatever you put here. So we're going to subtract whatever goes here. So x to the fourth minus x to the fourth is 0. No x squareds minus a negative. So that's really plus x squared is x squared. And then we're going to bring down the 5. We can bring down the 0x, but there's nothing there. So we're going to bring down the plus 5. And now x cubed doesn't go into x squared. So we are done. We have long divided. Okay, we've long divided correctly. And this is the remainder. The remainder, if you remember, goes over the divisor. So this is my new fraction. This is equal to this whole thing that's here. So now what do we do with this? So what we have is we have x plus x squared over 5 over x cubed minus x. The x will be part of your answer. It's part of your decomposition because x cubed went into x to the fourth x time. So it will be part of your answer. However, this x squared plus 5 over x cubed minus x is now proper. It's degree 2 on the top and degree 3 in the denominator. So you can do the partial fraction decomposition for this fraction, which happens to be the remainder of what you got when you long divided. So we are going to partial fraction decomp x squared plus 5 over x cubed minus x. So part of your answer here is going to be x. So let's just store it up here. We have x to the fourth plus 5 over x cubed minus x is going to equal x plus x squared plus 5 over x cubed minus x. And now we are going to decompose that. So let's do that down here, and we'll see what we get. So we have x squared plus 5. We're going to have to factor the denominator, take an x out, and then factor the x squared minus 1 again with difference of two squares, x minus 1 and x plus 1. And now we are ready to go. We're going to have three fractions, an x minus 1, and an x plus 1 will be the denominators. A, B, C, they're all linear terms. So we have A, B, and C on the top. We're going to go find a common denominator again. This stuff you already know how you do. You've done it a million times. So we have A, x minus 1, x plus 1, plus B, x plus 1, plus C, x minus 1. And now we're going to pick things for x. This should be the easy part now, although it's a lot of work. So let's let x be 1. If we pick 1, A will drop out and C will drop out. So that'll give me 6 is equal to 2b. So that means b, right over here, b equals 3. Okay, so we have b equals 3. Let's pick x equals -1. So that's still 6 on the left. A drops out, b drops out. I'll get -1 times -2 is 2c. So c is also 3. And let's let x be 0. We'll get 5 on the left. And on the right, a stays in. So it's going to be -1 times +1 is -a. So that makes a -5. And we're all set. We have our three variables. So now our final answer is going to be this fraction is equal to x minus 5 over x plus 3 over x minus 1 plus 3 over x plus 1. This is the correct answer. The long division counts as part of the answer. This was in the quotient. This is part of the answer. And then we decomposed the remainder, and that's what we got when we decomposed. That's the correct answer. Okay? All right, we're going to try one more just to make sure that you got the idea. And that should pretty much do it. So let's take x squared over x squared plus 2x minus 15. So again, if you look at the degrees, we have degree 2 in the numerator and degree 2 in the denominator. These degrees are the same, so you can long divide. So we have to long divide. You don't have a choice. You can't say, well, I'll just not worry about it. You have to long divide. So we're going to put a 0x and a 0 there in case we need it. So let's make that a square. So now x squared goes in x squared one time. 1 times x squared is x squared. 2x times 1 is 2x. -15 times 1 is -15. And now we're going to subtract whatever we put here. So x squared minus x squared is 0. 0 minus 2x is -2x. And 0 minus -15 is plus 15. So we have, so now x squared doesn't go into 2x. So that's our remainder. Our remainder is going to be -2x plus 15 over the divisor, x squared minus 2x plus 15. Okay? All right, now we are going to say then that this is equal to 1 minus, or I'm sorry, plus -2x plus 15 over x squared plus 2x minus 15. Now it makes it easier to see than what we just had. And now we are going to decompose the remainder. The 1 will be part of your answer. Okay, so let's go decompose the remainder. We have -2x plus 15. The bottom factors, x plus 5, x minus 3. So we're going to have an x plus 5 in the denominator, an x minus 3 in another denominator, an a and a b. And we have a negative 2x plus 15 equals a. This one needs an x minus 3. The b needs an x plus 5. And here we go. So now we're going to let x be 3. If we let x be 3, we get 9 equals 8b. So that makes b 9 over 8. So b is a fraction. That's okay. And then if we let x be negative 5, we'll have 25 equals negative 8a. So that makes a 25 or negative 25 over 8. So there's my a and my b. So now what you have as a final answer, and we can erase this part of it because we decomped it, and we end up with minus 25 over 8 x plus 5 plus 9 over 8 x minus 3. This is my correct answer, including the one from the quotient when we did the long division. Okay, and then we decomposed the remainder, and these are the two fractions we got out of the decomposition. And that's it. That's all you need to know for type 5. It's an extra step. You have to long divide. You now have to check the original fraction to see if the degree in the numerator is greater than or equal to the degree in the denominator. And if it is, you need to long divide to make the fraction proper. Okay? As always, thanks for clicking.